Okay, number 10 should be done.
Yes.
Okay, so exercises 1 through 10, those should all be done when we go to check them. Okay? There's no vague area there, right? Okay. So the only thing you guys have on your grade right now is that you guys haven't put in any of these exercises, right? The only thing you guys have on your grade right now is the quiz. Okay, so once we go put it on the exercises, that's going to affect a lot of your guys' grades. So make sure they're done. 1 through 10 all need to be done. Are we clear? All right. What's happening tomorrow? Exam 1, right? And it's going to cover everything. Now, if you guys go to your table of contents here, let's look at the front of your notebook. Okay. Let me pull up your actual notebook. Okay, if you guys look, this is your workbook. Okay, so you got one. This is not the right workbook. Give me 1 second, I got the wrong one. Hey, if you look here, these are Roman numerals, right? See the Roman numerals that I got highlighted right here? Number 1. We've covered 1, 2, and 3. Your exam will cover Roman numeral 1, 2, and 3. So up through exercise 10 is what your exam will cover. Okay, are there any questions there? Yes?
What will our next exam cover?
What?
What will our next exam cover?
Next stuff. I don't know for sure how far it goes. I have to go look.
4 through.
All you guys need to know is for tomorrow, you're going 1 through 3. Okay? Through exercise 10. If you can do all the exercises through exercise 10, you're good. Like you know what you're doing. If you don't know what you're doing on exercises 1 through 10, then the exam might not be so well for you tomorrow. Don't be that person. Go home and study. You should have started studying last night. That's just part of being responsible. Any questions regarding that? Okay, one more thing. Let me pull up another thing real quick. Okay, just so you know, this exam, okay, I'm going to read you the directions. Okay, I'm not going to show you the exam, but these are the directions. It is not open book. If you need help understanding a question, you can raise your hand, or you can wait quietly for someone to come help you. And wait quietly for someone to come help you. Here are the subjects that you're going to be able to have to do. So the types of questions. So I've write these down. These are the types of questions you'll see. I'm going to read them to you. So if you have a good idea to get a pencil or a pen, here are the types of questions you're going to see. For questions 1 through 13, you're going to match a word with a definition by filling in the blank. You're going to match a word with a definition by filling in the blank. For 1 through 13. Those questions should be very quick. They should be fast. So you're going to have to fill in a blank with a word by matching it up. So it's a matching. Okay, so that's questions 1 through 13. So the words you need to know. Here are some words you need to know. You need to know what a statement is. You need to know what a disjunction is. You need to know what a converse is and be able to use it. A negation, a conditional statement. An inverse. You need to know what a truth table is and how to fill one in. You need to know what an antecedent is and be able to identify it. You need to know what a contrapositive is and be able to write one. You need to know what standard form is. For the exam, standard form will just be writing out the statement in its entirety. Okay, not the negation definition that we saw. It'll just be writing out the definition, writing out the statement in its entirety. So if I give you if P then Q, write it in standard form, you'd have to write out the words for P and Q and to make an if-then statement. So I say, write a conditional statement for P and Q, or if I say write a disjunction for P with Q, write a conjunction for P with Q, write those in standard form, that means write them out. Okay? You need to know what a consequent is and identify it. You need to know what a biconditional statement is and identify it, write it. You need to know what logically equivalent means and write it. You need to know what a theorem is, and you need to know what a conjunction is. Okay, question 14. You need to be able to write statements. And I'll probably actually end up giving you statements for 14, but you ought to be able to write them appropriately. Okay? And then for questions 15 through 19, you'll have to be able to write the following. Your answer should be in standard form. You need to be able to write a negation of A. You need to be able to write a conjunction of two statements. You need to be able to write a disjunction of two statements. You need to be able to write a conditional statement using two statements. And write a biconditional statement using two statements. Questions? Yes?
How many questions are there?
27.
Okay.
Okay, question 20 is filling in a truth table for a conjunction, a disjunction, a conditional, and a biconditional. And for P and Q and not P. Okay? So you got to be able to fill in a truth table. When you have a blank truth table, the key is to label your first two statements. So if you have two statements, P and Q, you got to label those two statements first, and the rest of the table you can fill in. So if you have two statements, you're going to have a true, a true false, a false true, and a false false. If you only have two statements to work with from the beginning. Okay, that's just going to be the same every time. Do we understand what I mean when I'm describing this, you guys? Anyone need any extra clarification? Okay. Fill out a truth table from scratch. You need to be able to determine the truth value of a given statement using your truth table. So if you fill out a truth table, and I give you a statement, kind of like this, okay, if you fill out your truth table and you get a statement kind of like this is not the one you're getting, I just made this one up. If you get a statement like this, though, can you determine the truth value from it? Well, where do you start? Parentheses, so you'll figure out, is this true or false? Then you'll figure out, oh, this is a conditional statement. Is it true or false? You have to get this one before you can get this one. Once you get this whole statement, you say, well, is it true or false? And then you compare it with the disjunction of P. Okay? What? Depends on your cases.
No, during that sentence.
During that one?
Yeah, because P has a disjunction and
So, next, 22, question 22. Question 22 through 27. You're going to be given some statements. You're going to be given De Morgan's law of disjunction. You'll be given De Morgan's law of disjunction and conjunction. You'll get denying the consequent, negating the conditional to a conjunction. So, questions 22 through 27, listen closely. These are the example 12. You guys look at example 12 in your book, and example 13 in your books. Question 22 through 27 is very similar to those. Or exercise 10. Okay, exercise 10 is very similar to questions 22 through 27. No, you'll have some other statements. So it's very similar, though. Okay, if we're proving two statements are logically equivalent, what does that mean? Yes?
They have the same truth table.
They have the same truth table. Okay, De Morgan's law of conjunction is something that you're going to prove using a truth table. So what you're going to be doing is you're going to be given some statements using De Morgan's law of conjunction. You will prove that De Morgan's law of conjunction is true by showing that their truth tables are the same. So if you can fill in the truth table, that's all you have to worry about. Okay? Then you have to explain how the truth table proves De Morgan's law of conjunction. Well, if it proves De Morgan's law of conjunction, then their truth tables are what?
The same.
Same. Okay, real quick, I'm going to show you one little piece of the test because I think it's a little more difficult.
The thing's frozen.
I don't have it up yet. I've locked it so you guys can see it yet. So, this is questions 22 through 27. A little sneak peek, okay? There's no need to memorize because it's going to be given to you anyway. There's nothing to memorize here. There's no answers. So you're going to use these equivalencies. Okay, De Morgan's law of conjunction says not, right? P and Q. So the negation of P and Q is logically equivalent to the negation of P or the negation of Q, right? So what you're going to have to do, you're going to be given this part. They say, hey, look, find this, find this, find this. Like in example 10, right? Or exercise 10. We had this yesterday. You guys were told to do this, this, this. But then you have to write it like this, write it like this, write it like this. Right? Okay? So whatever your statements are, that's what you have to do. Then, what you're going to be given on question 26 here, you're going to prove De Morgan's law of conjunction. So meaning, you're just going to fill in the truth table. And you're going to show that this column is the same as this column. But you have to have all the other columns filled in. Okay? I just don't want you guys to get to this part on the test tomorrow and be like, oh my gosh, what do I do? That's it. I just told you what to do. Okay? Because I think this is probably the harder question. Look how many points this one question's worth. Do you think it's important?
Yeah.
Okay?
16.
26.
Okay.
Okay.
I thought it was 16 points because it was blocked by the engine.
That's a 10. Okay, questions? Yes.
Okay, so, I totally forgot, I'm sorry.
Can't remember that?
Nope.
Oh, yeah.
Oh, I remember. Out of how many points is this?
100.
So that's 10% of the whole entire exam.
Yep.
26.
Truth tables aren't bad if you just do them piece by piece. If you look at the whole truth table and think, oh my gosh, I can't do that, then yeah, you're going to be overwhelmed. Do a piece at a time. Okay, don't try to do the whole thing at once. You need to do, oh, I got to do this box first, then this box, then this box, then this box. And then you go forward. Okay? Yes?
How much is 7? How many points do you have to get to reach 70%?
70.
Because it's out of 100.
Okay, we're going to talk about tautologies and contradictions now that we've done our little test review. You guys just need to study tonight. I do want to go over exercise 10 really quick as well, so everyone go to exercise 10 first. Go to exercise 10 first, please. Exercise 10, please. Okay, we're just going to go over the answers for this. Because you guys were supposed to do it last night, right?
Yeah.
I didn't study it all.
Okay, this exercise 10. Okay, exercise 10 is using example 13 to kind of be an outline. So, consider the following statements. If you have 3 statements, they're saying write the negation of a disjunction. Write the negation of a conjunction. So this is example 13. that you use to help you on exercise 10. We're using these ideas, these compound statements. If you look at these compound statements, these are, I just showed you, these are going to be on the test tomorrow. Like, that's questions 22 through 27. I just showed you. So, if it says on number 1, write in standard form the negation of the conjunction P and Q. Well, we know the negation of a conjunction is right here. Okay, this is the negation of a conjunction. If I have this as my negation of a conjunction, or disjunction, sorry, I highlighted the wrong one. The negation of a conjunction is, if not, okay, I got the negation of P and Q is logically equivalent to the negation of P or the negation of Q. You need to write this piece. This means negation of a conjunction, right? Negation of a conjunction. That's logically equivalent to its disjunction, where both the P and the Q are negated. So you would write this piece. If they tell you, hey, this is what we want you to write this. If this is what they want you to write this. Because they're logically equivalent. That's what the question's asking. Okay, so on exercise 10, yes?
Who else was the one?
Just a mathematician. Right now, that's all I know. There's lots of different mathematicians that contributed heavily to mathematics. He is one of them. I think, if I remember right. I have to go back and look at my history, but
What if it's a girl?
very well could be. I would have to go look though. Or you can research and come tell us about it. Okay, Fred is not a fish or lemon is not tart. That's number 1. Number 2. Fred is not a fish and a lemon is not tart. So we're writing the negation of a disjunction. You're not writing a disjunction for number 2. Okay, the negation of a disjunction is the negation of the first statement as a conjunction with the negation of the second statement. Do we know where this is coming from? This is what I need you guys to understand.
Yes.
Okay, it's coming from one of our laws, right? So they tell you what to write, you're writing its alternate form. They tell you what to write, you write its alternate form for these questions. Number 3, 11 is not tart and Arbor Day is not in April. That's a negation of a disjunction of Q and R. Number 4, write standard form negation of conjunction of P and R. That would be Fred is not a fish or Arbor Day is not in April. Write in standard form the negation of if P then Q. So that would be Fred is a fish and a lemon is not tart. These are logical equivalencies to the statements that are given. Fred is a fish and a lemon is not tart. Yes? Huh? You don't understand the last one? Okay, we'll look at it in just a second. So, if P then Q, we have to write the logical equivalence to the conditional statement here. So, the negation of if P then Q, we look at it here. Negation of the conditional, that's what we're writing, right? You see that? That means you're going to write P as a conjunction with not Q. Okay? This is number 6, explain. So if I look at P is Fred as a fish. Okay? We're going to write that as a conjunction with not Q. And Q is Arbor Days in April, so the lemon is tart, so lemon is not tart is not Q, right? So you're going to write Fred is a fish and a lemon is not tart. Right there. Okay, so you use this statement, the negation of a conditional statement. Negation of a conditional, this is the example you use. So you're writing the second half, you're writing this part. They're telling you, write this as this. On all those questions, they're saying, look at the first one, this is what we want you to write, but write its logical equivalence. Is that good? Other questions? Okay, heads down. Heads down, heads down. Feels like they know what they're doing for the exam tomorrow. So raise your hands high. You feel like you know what you're doing for the exam tomorrow? Okay, raise your hand if you know what you have to do, but you're not quite there yet. You raise your hand if you feel confident that you can go home and study tonight. Not will you, that you could if you needed to. If you can go home and study, raise your hand if you can go home and study tonight. Okay, hands down, hands up. Okay, real quick. I'm going to take roll because I haven't been doing that, so need to fix that. So we're going to fix that real quick. We're going to take roll. Okay. Okay, listen for your name, please.
Listening.
Maybe at the lows. Okay, if I say it wrong, I'm sorry. Katerina,
What?
you're here, right?
Yes.
Roland. Go about what? Devin. Kinley.
Here.
Bridger.
Present.
Max. Giddings.
Here.
Raise your hand. Maya Headley. James.
Here.
Tret.
Here.
Abby. Go by Abby or Abigail? Okay. Boston.
Here.
Canyon. Damien. Hayden. Guys, I need you to raise your hands. I'm still learning names. Hayden. No Hayden? Chelsea.
Oh, that's in the second.
Why is he in this class?
Maybe not.
Rayleigh.
Here.
Tatum.
Here.
Billy. McKinley. Riker.
Here.
John.
Here.
Micah.
Here.
Kara.
She's not here. She's not here today.
Brooke.
Here.
Grant.
Sarah.
Maggie. Taylor.
Here.
Adam. Adam. Tilly. Huh? Violet's not here today. Nash. So Kara, Adam, and Violet not here, right? I miss anyone? Harley? What's your last name? Why am I marking it? Okay, good. Okay. Here we go. You ready? Hey, guys, let's go. We've got short time to get through this because we did some review stuff. So, Definitions today so far. Tautology. A statement is a tautology. Everyone say it.
Tautology.
Kind of a fun one, right? If and only if it is always true. If and only if it is always true. Wait for a second. A statement is a contradiction. If and only if it is always false. Hey, example. If we have statements P and Q. With these statements P and Q, if we're given the statements P and Q, we know there's a true possibility, a true false possibility, a false true possibility, and a false possibility. Okay? Not P would be false here. Not P is false here. Not P is true here. Not P is true here. Okay? So given that we start with these guys, okay, I've got some people doing their own thing. It's time to do this up here. So get with the program. Okay? So P and Q, if this is what's given, this is what we have. Now, Q or not P would be a true, false, true, true. Okay? So given that Q or not P, that means we have Q is true, not P is false. True, false, is that true on a disjunction?
Yes, that's true. That's true.
Okay? If I have a false, false on a disjunction, okay? A true, false on a disjunction, okay? A false, true on a disjunction. Right?
Yeah.
Everyone okay with that? Okay, now we have P or Q or not P. So we have to establish Q or not P first. So this would be, let's look at the first case. If P is true, and then Q or not P, that would be true. So it would be a true, which makes it true, yes? Okay. Then we have, so that'd be a true with a true to give us true. Then we have a false, a true with not P, or with P. With a disjunction, Q or not P, that would be false. A true, false gives us a true. Okay. Next, we have a P will be false. Okay. And so that's false with a true. What's that? Okay. Then we have a false with a true again. True. So this is an example of a tautology. This statement, okay, the disjunction of P with Q or not P is all true. Okay, in all our cases here. And each case is true. So this is what shows us a tautology. Questions on that? So if you get all truths down your column, that statement's a tautology. If you get all falses down the column, that statement's a what? Contradiction. Or no, not contradiction, sorry. Yes, sorry, contradiction, yes. Get my word mixed up. Everyone okay on that? Not too bad, right? Next is an example of a contradiction. So, example 2 here, on example 14, number 2. Okay, again we have our P's and Q's. Those are all assigned, those are all given. Then we have our if P then Q, if P then Q. There's a symbol missing. There should be a put that symbol in, please. A conjunction there. Put a conjunction there. Is your guys' distance symbol or is it just mine? Let me look at mine real quick. Yeah, we're just missing some symbols, so I don't want to. there needs to be another conjunction right here. Okay, conjunctions here. There needs to be one right here too. So put in your conjunction symbol here and here. Everyone got their conjunction symbol in? Okay. So now, if you're to fill out the truth table from scratch, this is what we get. Straight falses is a contradiction. Questions? Yes.
Okay, so I'm gonna re-ask my question that I asked earlier.
Okay.
So on page 25, exercise 11, it leaves it all blank. And then, so can we just put like, in all true, if we want it to be like all true, or?
What do you mean it leaves it all blank? Which part?
Exercise 11, all the truth table blank and you have to fill it in.
Hey! She's talking, you're not, right? Please! I have to do this every day with you guys. If someone else is talking, you're not. She's got a great question. It's about your exercise that you're going to have to do. Hey, ask again, please.
Okay, so on exercise 11, the truth tables that they give us are blank.
Okay.
So, if we were to put in like all true or all false or something like that, then on like one row on purpose, would that work? Or
You have to make sure your statements are accurate. Here's the thing. So if we look at these tables, okay, each of these, you have P, then Q, right? These are just possibilities of P and Q. So these two rows always pretty much have to be the same. If there's two statements, the two rows have to be the same each time. So notice this is true, 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 false, false, true, false, false. You'll have to do this tomorrow on your exam too, where you have a table from scratch. Fill in these two columns first if you have two statements. If you have three statements, fill in the three columns first. Does that make sense?
Yep.
So this is true, 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 false, false, true, false, false. These account for all the possibilities of P and Q. P could be true and Q could be true. Or P could be true and Q could be false. Or P could be false and Q could be true. Or they could both be false. Okay? So you have to account for all the possibilities. So that's what the truth table does, is it accounts for every possibility where P is true and Q is false. Or false true, or true true, or false false. Okay, so it accounts for all those possibilities, given what are their truth values in this case. Well, here's what happens when you have a true true with P and Q. True, true, and the last statement's false. So you can't just put in true straight through, thinking it's going to be true.
okay.
Does that make sense? Now, a lot of times, what we've seen, yeah, these are going to be a lot of, if you have true, true here, in a lot of cases, it's going to end up true all the way across, but not all cases, as you can see here and here. It's not true all the way across, right? So you can't just throw in true all the way across. No, that's what you're asking, right? Yeah, so you can't just put it in there. Yes?
Okay, does it matter what column you're in? If it's all false or all true, does it matter what column it's in?
So a tautology is where they're all true, right? The contradiction is where they're all false. So no, it doesn't matter which column, because each column represents a statement. So this is the column for statement P. This is the column for statement Q. This is the column for statement if P then Q. This is the column for if P then Q, and as a conjunction with P. And this is the column for if P then Q, with a conjunction with P and a conjunction with not P. So they all represent their own statement. So this is saying for this statement, it's always going to be false in all cases P and Q. This statement is going to be true, false, false, false in statements P and Q being with this. So if P and Q is true, both are true, this statement has to be true. If P and Q are true then false, the statement has to be false. That's what it's saying. So good thing. We're learning how to read our truth tables better. Good. Since you had a question already, I'm going to come over here with it, okay?
So on the exercise 11, if they're just asking for a tautology on the one, is it okay if there's two tautologies in something?
There could be two columns that are all true, yes. Could it happen? Yes.
And it's okay if it is?
Could it happen? Yes. Does it happen all the time? Not necessarily. I mean, it didn't happen here. We only had one true column, right? So could it happen? Possibly. We'll have to look. Yes?
How do you know a statement's going to be constant?
What do you mean?
Over here, on like number 50.
This one? Like,
Exercise 11, like how do you know what statement's right?
So right now, they're telling you, so on these questions, I'm gonna use this example here. They say, hey, this statement is a contradiction. You're just showing, yes, it is. Okay? By showing that this is all false. We'll come to that one in a second. We're gonna do a couple together as a class. Yes?
Well, so I went on ahead a little bit. I just went over the top one again, and I got a false on the statement that wants me to prove there's a tautology.
Where are you looking?
Number one, exercise 11.
Exercise 11?
Exercise 11.
Not this example.
No.
Okay. We're gonna look at the exercises in just a second. Okay, let's look at example 3 real quick, then we're gonna jump to exercise 11, 'cause that's where some of you are at. That's okay. What we're just gonna notice here, our tautology is this statement. Okay? You fill out your truth table. Again, you have to start with these columns first. Then you start with this column. Then this column. So we're working from the inside out. Let's look at this. We find our conditional here. Okay, find our conditional as a conjunction with P. Here. Okay, find Q. This should be not Q, actually, I believe. No, that's just Q again. Yeah, that's okay. Hey, double. Hey, you did it twice, that's fine.
Wait, you could do that?
Yeah, you can put another Q in here just so it's closer to this statement. That's fine. It's the same thing as that one over there. It's just restating Q.
Oh, okay.
Yeah, it's just restating Q so that you can use it here. Okay? And then we see that the statement's going to be true, true, true. We're going to practice this as a class. You guys are going to walk me through this, okay? So this is going to help you for our test tomorrow as well.
I have to go home.
Hopefully we can get through most of this. We're going to try to do 1 and 2. You guys will do 3 tonight for your homework. Okay? Or this isn't going to be due till Monday. Because you got your exam tomorrow, right? So you don't necessarily need to finish this one tonight. It's due on Monday. Okay? Yes?
I have no number 1.
Okay, we're gonna walk through them and make sure we're right. Okay? Okay, number 1 here. I can get it. I really need it. Okay, we have this truth table. We need to use the truth table to prove that the conjunction of if P then Q with not Q as a conditional statement with not P is a tautology. Okay? So we got to write the condition of the statement here with not P and show that it's not tautology. So what needs to be in this column to make it a tautology? All true. Okay, that's what we're going to show. I need someone to come fill in the possible P values. Okay, I need someone with possible Q values. Ready, go. We'll see. You guys got it?
No. Let me go check my keys.
Okay, think about how every one of these start. What 2 statements do you show first?
True and then all false.
So think about this. Let's back up for just a second. If you go to our previous examples, okay, look at number 3 here. Look at number 3. Look at how P and Q always start on every one of these. Look at how P and Q always start, you guys. Look how P and Q always start. On every one of these examples, examples 1, 2, and 3, everyone, look at how P and Q always start. Okay, now fix those accordingly. Okay, I'm gonna give you guys about 10 more seconds.
Mr. Rice, on P, it's true, false, true, false. And on Q, it's true, true, false, false.
We obviously have different truth tables.
Okay. It doesn't necessarily have to be like this. You can put the true true down here and the true false up here. But you need each situation. Anytime you start these truth tables, you need each situation. You need a true true situation. You need a true false, a false true, and a false false. If you have two statements. If you have three statements to start with, like P, Q, and R, you would have more to do. Okay, you'd have more rows. So each time, if you have two statements, you got 4 rows you have to start with. You need each situation. So this situation is a true, false, false, true, and a false, false. Okay, I need the not P and not Q for each situation now, according to the row. Okay, not P and not Q.
Is that supposed to be?
Okay. Do we agree with them? Okay, if P is true, then not P has to be false. If P is true, then not P has to be false. False, true, false, true. Dang marker. Okay, and not Q is according as well, right? We're good there. Okay, now here's the key. We have a conditional statement. If P, then Q. When is a conditional statement true? When is it true? Yes. All of them are true? Okay, what else? What do you think?
When, when they're both false.
When they're both false, okay. Yes?
Isn't it true when it's not true, false? When it's true, false.
Good, you guys are all right. You guys are all saying the same thing. So, if I have a true, true, that makes my conditional statement what?
True.
Everyone with me, okay? Everyone. If I have a true, false, what's my conditional statement?
False.
Okay? If I have a false, true, what's my conditional statement?
True.
Okay? If I have a false, false, what's my conditional statement?
True.
True in this case, right? Okay, now we have to have a conjunction of not with not Q. A conjunction with not Q. A conjunction with not Q. Think about it. What's special about a conjunction? What do we know about conjunctions and their forms and their truth values? Yes. Okay, we got people talking and being rude, so when they're done, you can speak, okay?
Conjunctions are only true when both the values are true.
Only true when both the values are true. So, if my conditional statement is true, which it is here, not Q is false, what's this conjunction? False, because they're not both true. They have to both be true in a conjunction to be true. Okay, now, my conjunction is false with not Q. That's true in this case. Not Q is true in this case, so it's a false true. What's my value here? False, because they both have to be true for a conjunction. Okay, my conjunction is true, and not Q is false. So that's a true false again, so that's going to be false. Okay, my conjunction is true here, and my not Q is true, so that's going to be true. This one's almost a what? Almost a contradiction. This one's almost a tautology. There's one value in both cases that make them not a contradiction, not a tautology. Okay? So now we've got to finish the last statement. So here, we've got our brackets. Notice how they set up these truth tables. The truth tables are set up so that you have the insides of the bracket right here. You have false, 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 true. So if the insides, this is a conjunction. Okay, we're taking this conjunction, we're taking its truth value with a conditional statement of not P. When is a conditional statement true or not true? Yes?
It is not true when it's true false, but then in every other case it's true because false true is true.
Okay.
False false is true, and then true true is true.
Okay, so we have, on the first one, we're going to have a false with not P. False with not P, that's a false false, that's going to be true. That's what we want, right? We want truths in this column because we're trying to show that this statement's a tautology. Then we're going to say, well, that's a false with not P. Not P is false again, so that's going to be true. Okay, false with not P again. Not P in this case is true. So that's a false true statement, which makes this true. Then we're going to have a true with not P. True, true, true. Do we have a tautology?
Yes.
Yes, we just proved that. That this statement is a tautology. We just proved it. Okay? Questions? Heads down. Who feels like they could fill in this table by themselves? You could fill in this table by yourself. You could fill in the table mostly by yourself. You could get at least half the table done by yourself. Raise your hand. Half or more. Let's do that. You can get half or more of the table done. So if you can do the whole table, raise your hand still. You can get half or more. Half or more. Raise your hand if you can at least start it. At the very least, you can start it. Okay, hands down, hands up. Very good. Questions now. Okay. So this next one, number 2, they're asking, use the truth table to prove that it's not a tautology. So what can't happen here? We can't have all truths anywhere. Right? And notice they haven't filled in the blanks for us.
Yeah.
We need to practice filling in the blanks. So, if you model it after all of our other examples, you're working from the inside out. Okay? So, if we model after this up here, we need a not P. We need a not Q. That's got to happen. Because we're going to use not P and not Q. So, we got to have those values. Then, we're going to have if P, then Q. That's got to happen too. And we need the conjunction statement right here. So if P then Q as a conjunction with not P. Then we got to write the whole statement. We're going to write this conjunction as a conditional statement with not Q. So we're going to say if P then Q as a conjunction with not P, as a conditional statement with not Q. Not Q. So that's how you fill it in. Yes? Talk loud for me.
Did we change the not P not Q around? Because it says, I don't know what happened, but on the end it's not Q.
Right? Not Q here.
Oh.
So yeah, we're using this one now. These are two different statements. That statement up there is very similar to this one, yes? Okay, that statement up here is very similar to this one, right? We're showing, hey, they're very similar. We're going to show that this statement's not a tautology, though. Okay? So if we go to fill it in, we have a true, 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 false, false, true, false, false. Not P would be false, false, true, true. Not Q would be false, true, false, true. Our conditional statement is going to stay the same, right? Because the table is the same up to this point. So what goes in this column? We have a true, true, which makes it true. A true, false, which makes it false. A false, true, which makes it true. False, false, which is true. Okay, I want you guys to try to fill out those last two columns. So what you guys have to do by Monday, fill out these two columns and do number 3. Okay? We are done for today. Fill out those last two columns and do number 3 all by yourself. Good job today, guys.